Hello everyone, welcome to part 3 of topic 7. Topic 7 is related to machine learning techniques, and in this part 3 we will talk about, or at least we start with the neural network and to see what neural network means and how it works, and also why we use them. It is also called black box regression, and we will see what that means. Okay, so neural networks is one of the most important techniques in machine learning. It has been there for maybe more than 25 or 30 years is known the idea. So it is some kind of adaptive filters, we can see, or we can say that, but the way of adaptation of the multi-layer neural networks, as we will explain it shortly, that it has taken some time before we use what is known as backpropagation algorithm in order to adapt the neural networks. But before we go to the details of the neural networks, it is good to start with the concept of maybe the functions of brain neurons, because it was the basis or the neural networks was inspired by the functionality of brain neurons. Okay, so also it is called black box algorithm or black box learning algorithm because we don't need to relate the exact equations with the data or with the learning process. If you remember, when we talk about linear regression in part 2, we gave that equation and we saw that how the parameters of the equation is somehow related to the attributes. But in the black box, we don't know how these things are related to each other. What we know that how to make the output is to be very close to the actual output, the output of the neural network to be very close to the actual output, not only during the learning process but also during the validation and test and working process. And then we can say that this neural network has learned the operation. Okay, if we start with the real neuron. So a human brain, for example, consists of about 100 billion neuron cells. Each neuron cell can be connected to from 1,000 up to 10,000 neurons. So you can see that it is very, very huge network, very huge network. It is about 10 to the power 12 or something like that of connections. So we can see this as parallel processing. You can see that if we assume that every neuron as a small processor, then you will have 100 billion processors connected to each other. So it is extremely powerful and efficient and high efficient processing unit. So but how the learning is done? What is the adaptive thing during the learning? Because when we learn something, there should be some adaptive part in our brain that it can save information, it can save memory, it can learn that we learn something new, we have our ideas, our dreams, everything. So how can we do that, or what is the responsible part of in the neuron? So to see that, the neuron itself consists of the neuron body, as you can see it, that we have this is the body or the cell body. Then we have the nucleus inside. Then we have axon, which is the cell output, and then we have this axon is connected to other neurons, and they are connected through what is known as synapse. So in the synapse actually is the part which is adaptively changing during the learning. And you can see that the input also of this neuron is coming through other neurons, as you can see, and they are connected through the dendrites. So the dendrites here, they are connected with, this is the cell input, and we have everywhere we have synapse. So wherever you have synapse, then it means that you have adaptive part here. The adaptive part is here in the synapse. So, for example, the inputs coming during the learning, these neurons have inputs. It is like it is called electrochemical signals, because it is a chemical flow, but it has also electrical effect. And when this electrical comes to this or this chemical comes to this synapse, so during the learning, the synapse working as a gate, so it might make this signal to go through, or it might block it. So during this blocking and allowing of this one, it makes the adaptation in your brain, in our brain, in order to learn or to memorize, in order to have our provide our ideology, and many things are related to these synapses. So those are the points where the adaptation of our brain happen. So it is through the synapse. Okay, now we like to build similar way, but in mathematical representation of this previous cell. So now you can see that this is the inputs that we have here. Okay, and we can represent those synapses as like weights. This weight can be like gate, or it can be just weight to control the input from the other cells as well. And also we have the output, and there's some operation happening inside this one, and then this operation goes out and it makes the output to the other neurons. Okay. Now we can represent this by using this equation. So we have those weights, adaptive weights. Those adaptive weights, like it's working like synapses here. Those adaptive weights, and then we have the inputs, and then we have the cell body. This is the cell body, where we have the summation point for all inputs, and then we have some function here. This function actually makes the output. So this function, because the actual function that in the neuron is, as I said, it is a gate. So it might make output or not output. So if the input comes up to certain input, then it will fire the output, otherwise it will not. But actually, during the learning process, we need to find the optimum weights. In order to find the optimum weights, when we talk about optimization, then it means that we need differentiation. This kind of function doesn't have differentiation. When you have this step output, then it doesn't have differentiation. We cannot differentiate such kind of equation. The differentiation is not a function. When you differentiate it, you will have delta, direct delta, which is not function. Okay, or not regular function. In that case, what we need to do, we need to approximate this one to be like more smooth. So a smoother type, it can be something like that. So it can be something like that. So, and this can be represented, for example, by using, it is called tanh function. This is the tanh function, or it can be like logistic function. These have the similar and smooth type of this triggering or gate function. Okay. However, of course, we can use different kind of equations. It can be linear, like this one. Okay, it can be like 0 and x, so it can be based on maximum. It can be nonlinear as well. It can be tan inverse. We have different kind of functions, and each function, it has certain application. And one of the possible activation function is given in this way. Okay, it is called similar like maximum 0 and x, but it has some limitations, so it will not go to infinity. Okay. It is it will be linear within some like range. This one, it is linear to be within some range. So it can be like from 0 to x, and then after that it becomes like before less than 0 is not linear. It will be close. It will be like gate 0, and after x max it will be support or stop at x max. So it can be something like that. So the function will be 0 until 0, At 0 it will increase like x, and after that it will be continuous like that. So it is also some kind of approximation to the original like gate function in the actual cells. Okay, we can have actually multi-layers, as you can see. So we have the input layer, and then we have hidden layers. We can have any number of hidden layers. Then we have the output layer. Then we have here the outputs. In the output layer, actually, the number of neurons in the output layer must be the same as the number of outputs. For example, in the example that we mentioned before, in the part 2, when we talk about the building algorithm to estimate the second-hand cars, and we said that we have two outputs. Y1 is the price, the sold price, and Y2 is the number of weeks to be presented in the system before it is sold. So now we have two outputs. Since we have two outputs, then we should have two neurons in the output. So because each neuron in the output representing the output itself. If you have only one output, then of course it will be one neuron in the output layer. Okay, then in the input layer, we can have any number of neurons, because the number of inputs is not necessary to be the same as the same number of neurons in the input. So we might have only one neuron with all in inputs. However, as we increase the number of neurons in each layer, then we increase the capability of this neural network to solve more complex maps. And also when we increase the hidden layers, we also increase the number or the complexity to solve very, very complex relation between the input and the output. Sometimes the input and the output can be very, very high non-linear. It is very hard to represent them with a mathematical equation, but using like multi-layer neural networks, then we can have the relation based on data. So we put data and we put the desired output. The desired output works as a teacher. So we teach this neuron, and what is adapting during the teaching are the weights. The weights are those which are adapted. Okay, now there's a simple but important question. How could we adapt the weights? Of course, adapting the weights, that we compare the output. For example, Y1, we compare it with the desired Y1. So we have here Y1 desired. So this is like the teacher. Okay, so now it gives some output, and then we subtract them to the plus minus. Then we have the error. Okay, this error could be used actually to reduce the errors by adapting the weights. However, the tricky question here, it is easy to find the error in the output, but and this error can be used to adapt these weights. But how could we adapt the hidden layer weights? Because we don't know what is the desired output here. We know what is the desired output in the output, but we don't know the desired output in the hidden layers. Okay, so it is not easy to find. Actually, this question becomes around and makes the neural network application very limited to only one layer for several years. Before, I don't remember now the year when they discovered the backpropagation. Maybe it was in 82 or 84. I don't remember very well now the year when they discovered the backpropagation algorithm, where the error here could be backpropagated to the hidden layers, and then we can adapt the weights of all layers. And actually, the algorithm backpropagation algorithm is very simple, but in the same way very clever. So it was just making some kind of chain rule in the derivation. We will take this into detail in our machine learning course. There is another course, mathematically based course, where we explain the details of how to find these adapting weights based on the backpropagation algorithm. However, it is not necessary to know the mathematical details as far as you want just to apply them, because all programming now packages, they came with built-in backpropagation and almost all kinds of machine learning algorithms ready, like in Python or in Julia or MATLAB or Octave, so you can use them. Okay, yes, This is the main word of the back propagation to calculate the hidden layers weights. Okay, so this is the concept here. You can see, so we have the output, we have multi-layer networks, we have the output here, we have teacher, okay, then we have the error, and then based on the error we can have learning algorithm, back propagation learning algorithm, in order and adapt the weight. So the input here can be the attributes x1, x2 up to xm. For example, if it is related to the cars, then it will be the brand of the car, it will be the age of the car, it can be all car attributes as input, and maybe the output is the sold price. So here we put the input from the database, and here we put the sold price. Maybe before the learning, maybe when we put the input to this multi-layer networks, and the output can be, for example, say that it was sold after, let's say, 70 weeks, but the actual result was only 10 weeks. Then difference 70 minus 10, it will be 60. 60 is the error. So the error comes there, and it will try to optimize the optimum weights in order to reduce this one. Then we put the second input, the third input, the fourth input, for example, 5,000 inputs that we give, and then once we complete the 5,000 we can repeat it again. So we call it number of epochs, how many times that you show the data, because the data cannot be learned from the first presentation, so you need to repeat this many times. So it can be 10 times, 20 times, 100 times, and based on that you can observe how the error is decreasing during the training, okay, the mean squared error during the training. And then after that you can stop it, the training, and you can try with the validation set. So you apply the validation set, and then you can see if it works. You compare the validation output with the teacher output, because we know the teacher output in the validation set. So then we can say that if it has learned the relation or not. However, that we have several questions like how many layers that you should use, how many neurons in each layer that you should use, what type of activation function that you should use. Those questions actually can be like based on trial and error, or based on the type of data itself. Okay, so for example, if data, the output data, or the output here, for example, cannot be negative, then of course you can take the activation function here that it is not negative, so it is always positive, 0 or positive, and so on. Yes. We have several problems actually associated with the neural networks. So one problem that the input should be independent. For example, as means the attributes that you give, they should be independent. It doesn't work directly. For example, if you have correlated input, or you have correlated data, so it means that if you have x1, x2 up to xm, and we have the output y, then this is for example, for the first car we put here, for the second car we put the values here, for the third car we put the values here. But now between those cars, those cars should be independent to each other. So it is the prices or the attributes and the price for each car. Okay. However, if we like to see, for example, the attributes is for the weather. Okay, for the weather. So for the weather now we have the temperature today. Okay, we have the temperature today, or the average temperature today, and then we have the pressure today, and maybe the cloud situation. Okay, and our output is it raining or not? But this is the days. This is day 1, day 2, day 3, day 4, and so on. In this case, we cannot say that these days are independent. It is, if you assume that they are independent, the bias in the result will be very high, and it might not get good result at all. Okay, because even the temperature here is like, for example, very low, and the pressure is everything here. For example, refer that there is no raining, but it also depends on the previous day, how the previous day was, and what will be the 2 days ago. So actually, in order to get good approximation or good prediction, you need to know also the previous days, how it works. So this way, by using the neural networks that feed forward neural networks directly, it might not work in a proper way. Okay. Also, there is another problem in case of several hidden layers. If you have many hidden layers, more than two, so you, for example, you have the output layer, you have the input layer, but you have hidden layers. So if you have more than two hidden layers, then the learning algorithm can easily trap it in any bad local minima. So because the learning process depends on what is known as a steepest descent algorithm. It is one of the optimization techniques that we use in order to find the optimum weights. The problem that in this steepest descent algorithm, it is, for example, assume, let us take only one case. So if we have like this is the efficiency or this is the error that we are looking to find the minimum error, and assume that the relation is in this way. It is clear that this is the minimum error that we are looking for. So when we reach here, we achieve the minimum error between the teacher and the actual output. And now, if you are here, then steep descent, it means that you are working with related to the differentiation of the error. Okay, so you are going like in this way. When you reach here, this is called local minima. Okay, in this local minima, the differentiation here is equal to 0. Okay, since the differentiation here is equal to 0, then you cannot make any further adaptation. So you will trapped here. Okay, but the error here is still large. Okay, now we are talking about only one input, but assume that in reality that we have maybe hundreds of x1, x2, we have multi-dimensions, and we might have like almost infinity number of local minima. And this number of local minima increase as the number of hidden layers increases. And because of that, we can trap it in any local minima. Of course, there are some techniques in order to get out from this local minima, like using what is known as handling techniques by pushing some noise, and this noise can be reduced with time. There are many different techniques in order to get out of this local minima, but even when you get out from local minima, you can trap in another local minima and so on. So the algorithm can be very complicated. The learning process may take very long time when we have large number of hidden layers. How to handle this problem? The handling of this problem by using deep learning algorithm, as we will see later. Okay. Finally, that also when we have many inputs and hidden layers, the learning process requires intensive computing, as we mentioned before. Okay, one example for having too many input is the images. So when you have images, for example, let's say that you have image with 1 megapixel. So when you have 1 megapixel image, it means that you have 1 million point. Okay, each pixel can be input. So now we have a neural network with 1 million input. Okay, and now if you have many layers, you can see that the learning process can be almost, useless here. So it will take very long time if we use the conventional neural networks with image processing. So this was the motivation for the deep learning. Actually, deep learning is nothing as just a neural network, multi-layer, but with like some much light computation for each layer, and we avoid to use backpropagation. There is no backpropagation there. There are some simpler techniques like convolutional layer, for example, and we will talk about this later. Okay. How to handle the problem of time series. So if you have time series data, it means that it is related data like this one. for example, stock market. And now we cannot say that each point is independent of the previous point. So they are dependent on each other. They are correlated. In order to deal with correlated input, then we can modify a little bit the neural networks in order to handle this kind of correlated data by using what is known as like delay line. So here we have delay line. It is it is like filters, moving average filter. So you have here the input, and then the input can go here after k minus 1, k minus 2. This is for the first input. So we take two previous samples, and I2 also we take two previous samples, and then we use the conventional neural network. So this is one simple, very simple realization. How can we deal with data with memory? And also we have recurrent neural network. It is also where the neural network is not feed forward, but the data from the neuron can go back, maybe can go back to the same neuron, or can go back from layer to layer. And in this case, we can handle the gate or the memory that we have about the process. So when we have process with memory, then we can realize them with this recurrent neural networks. One method of the neural networks is known as long short time memory. So we can have like long and short time that we memorize the last data that we have, so it is not go away. As I mentioned, that the deep learning is multi-layers. It is multi-layered neural networks, the same as before. But now, if we have image, for example, we can have convolutional network here in the beginning. So it is just a linear filter, and we can extract part of the data or some part of the data, and then we can extract the second part of data with another layer, and the third part of data. So we can divide the data or the image into layers, and each layer extract part of the information of data, and then we use actually maybe last layer can be just normal neural network. Then we have the output. So when we have error, then each layer can work like in efficient way. And also we use some kind of it is called like quasi-linear, which is like this 0 less than 0, and it is linear, and then we have some maximum. So with this activation function, the learning process can be much faster than using some other kinds of like logistic or tanh function. I don't want to spend long time here, as well as this topic also covered in different courses. But the important thing to remember here, that deep learning is a multi-layer neural networks, but with certain functions that it is much faster, and they can handle large size of data like images. Okay, now we come to the unsupervised learning. In the previous, we saw the regression and classification. Both of them, they are supervised learning, and also we saw a little bit about neural networks, the main concept of neural networks, and how it is used in the learning. Now, in the unsupervised learning, it means that we don't have labels. So we have data without labels. Okay, how could we treat it? Such kind of data. Sometimes even we have labels, but we don't use them. Because when you have label, what is the meaning of label? Label, that means that maybe someone bought this label or some measurement, but this measurement or the person that who give label, that as we mentioned about expensive or fair, or this can be biased. Okay, so now if we ignore the labels, or we use the labels as part of the data itself, and now we try to treat with data as like raw data. For example, if we have list of company attributes, for example, number of employees. So we have many companies, number of employees, revenue of a company, size, activities, and so on. And we don't have labels. For example, the performance level of this year, of these years. For example, for each year, what was the performance level, and so on. We don't have such labels, but we have only all just raw data, Excel file, large Excel file. Okay, and now what we can do here, one of the techniques that we can cluster this data. Clustering data means that with these attributes and the using some certain kind of algorithms, and these algorithms start to find the statistical like similarities between this input data. And after running this software or this code several times, then you may end up with some kind of clustering. So they will start to cluster these companies together, and cluster these companies together, and cluster these companies together. And after that, the second step came that you start as a data scientist or as interpreter. Then you can look to this data, why these companies they are shared together, what is the similarities between these companies. Okay, so you might start to find some new kind of information that even you didn't think about before. Okay, so you can find, for example, all these companies, they face difficulties, for example, and then you can start study what is common between these companies that they face these difficulties. Then you can find, or you can put your thumb on the problems that makes difficulties for companies. This is just one example. So now we can use them as, this is called clustering algorithm. It is not classification. Classification means that you have labels already. Clustering, that we don't have label, but we cluster the algorithms. So we have actually many different techniques for the classification. One of them is, or for clustering, sorry, one of them is called k-means clustering. So we have, for example, such kind of data that we have in the beginning, and we have two attributes, and we have some companies here, for example, and then we start with some initial guessing for the mean, for the average, and then after running this code several times, you can see that we will have a cluster 1 and a cluster 2 and a cluster 3. And actually we can, if you start with different mean, then you can have different clusters as well, like this one. So here we have only 2 clusters. Here we can have some kind, 3 but different way of clustering, and we can have this one. So it depends actually in the how we start the initial condition and what is the application. And it doesn't mean that only one of them is correct. It doesn't mean that, but it means that it is based on what feature that we are looking for makes the cluster. So if you have, for example, database, large Excel file, and you make the clustering algorithm, you cluster your data in different way, then you can start studying them. Then you may rerun the clustering process, but with different initial condition. You end up with different clustering, and then you can restart to study them. And every time you might find a new kind of like knowledge based on this clustering process. The final thing today is the reinforcement learning. What we have seen before, supervised learning or unsupervised learning, regression, classification, clustering, you might observe that that all of them depends that you have data already. So you have data, then based on data you start make learning process. Okay, but now if you don't have such kind of data, okay, for example, you have this robot, and we put the robot inside this maze, and this robot has maybe camera and has sensors, okay, but we didn't tell anything about the robot, about the maze itself, and all what we told that this robot will get like positive point if they get out from this maze. So they will get reward if they got out from this maze, and it will get, for example, maybe punishment if they didn't get out from this maze within certain time. Let's say it is T. Okay, now we bought this robot start to move. So now when it start to hit the wall, then they know that they will stay there and the time is ending and they will not be able to get out. Then they will get punishment. So they will start by itself to have like to build their own knowledge, that they use what is known as some kind of hidden Markov chains or the hidden Markov models. mathematically how to adapt it. So based on this adaptation, so they know that they should avoid hitting this walls, because hitting the wall, it means that they will trap there. So this will avoid, but they will get it by itself. And after that, they start to, for example, try something else, of try to turn to the right, and then maybe they trap it again, so try next time to try to take to the right and to the left, and so on. So it can work in this way. Maybe it needs like many times to repetition. Of course, if it is on the computer, then you can make the computer working like thousands of times, then until they build their own knowledge, and then they know how to like manage to get out from the maze. And now if you take this robot and you put it in a different maze, then you can observe that it might take shorter time, because they built some knowledge how to avoid these maze like tricks. Okay, so this is called reinforcement learning. So in the reinforcement learning, we don't have teachers, we don't have the label, we don't have the correct answer, but we have just to as a feedback, as a punishment or reward. Reward, punishment. This is wrong. This is right. This is wrong. This is right. But we don't show the actual answer. So this is the way how the reinforcement learning works. So it also only use a critic. Okay. So mathematically, this could be represented in this way. So we have here the agent, the intelligent agent. And the intelligent agent, it has sensors looking to the environment. We have high uncertainty in the environment, but even the measurements here can be incomplete, it can be noisy, it can be corrupted, okay? And then the agent will take action. Of course, the action will affect the environment. So for example, moving the robot, when you move, then the environment for the agent will be changed. Okay, so taking actions, and based on the actions, the actions will affect the uncertain environment that we have. And then sensors looking again, and here after some delay, because we have delay before we get the reward or the punishment. So after that, they might get reward if they succeeded, and they get punishment if they fail, for example, within certain time t. It is the same as we assume that we have intelligent agent working chess, for example. Okay, working a chess. And then we have a working against, for example, intelligent agent A working against intelligent agent B. Okay, and now they try to move, for example, any item on the chess, for example, forward, and if they move it in the wrong way, they will get directly like punishment. So they know after some time how they move the items in legal way. Okay, and then after time t, for example, or at the end of the game, if they succeed or they win the game, then of course they will get reward. If they fail, they will get punishment, either one of them. So assume that you put both like players to work like this chess like millions of times. So you can see that this intelligent agent, each one of them, they will start to build their own tricks, their own techniques in order to play the chess game. Of course, you can change that. It can be the intelligent agent against a human, for example. And then they play many times, then they can build their own strategy. What is the difference between making this machine learning based on the reinforcement learning or based on the learning process? Because we have already in database that those are famous in playing chess. We have their record, how did they play, and of course we can make this learning to the intelligent agent. But in this case, the intelligent agent will be only their capability will be restricted by the human way of thinking, because they learn their own ways how to play. But by using reinforcement learning without showing teacher, without showing how to play, we just show that it is reward if they win and punishment if they fail. So by this way, the intelligent agent might be able to build their own way of to play this chess, and they can create their own tricks to and strategy how to play and how to defend. So this is the good thing with intelligent agent. But of course, one of the big problems in reinforcement learning is their like limitation because of what is known as dimension curse, because it is needed to play it like maybe millions of times in order to get something useful. Okay, so we have now done with this topic 7. So in topic 7 we introduced the machine learning. What is machine learning? What are the main concepts of machine learning? What are the problems of machine learning, like memorization or overfitting or underfitting? And also, what are the rule of data? What kind of data that we need? Clean data is very important for the machine learning. Then we introduced some kind of regression, and we took only the simplest one of the linear regression. And then we introduced the classification, types of classifications like linear and non-linear, and then we gave just a general idea about using this non-linear to linear tricks to convert from non-linear to linear by using larger space. And after that we introduced the neural networks. What is the concept of neural networks, why it is a black box like regression or black box model. And after that we also have very fast like introduction to what is the meaning of deep learning, what is the meaning of recurrent neural networks, and then unsupervised learning, clustering, and finally the reinforcement learning. So as I said, that it is only one lecture about machine learning. We try to just introduce them in very fast way. For those who are interested to know the mathematical foundation of each algorithm here, then I just suggest you to attend our course Machine Learning, which giving every spring, where we give the mathematical foundation, the theoretical foundation of machine learning based on stochastic and probability theory, and also based on linear algebra and optimization techniques. And for those who are more interested in the application of machine learning, not in the mathematical foundation, then we have also another course is applied machine learning. The last part in my theme, in theme 2, it will be topic 8, where we talk about the conflict of interest and game theory and decision making, how intelligent agent can take like decisions and make like reasonable decision. This will be our next topic. Thank you very much.